Section 1.6 is about quadratic equations, and while we're working on quadratic equations, we will see a few complex numbers thrown in there. I'm going to teach you 4 different ways to solve a quadratic equation. For the most part, you can choose the method that you like the best, but it's usually better to choose a method based on what the equation looks like at the beginning. For example, the first method is called the square root method. If you want to use the square root method, usually you just have something that's squared and then one other thing. And what you want to do is isolate the squared part. So in this particular problem, we're going to add 9 to both sides. So this is 0, and we get x squared equals 9. To get rid of a square, you take the square root of both sides. The important thing to remember is when you take the square root of both sides of an equation, you have to consider the positive and the negative solution. So in this case, x would be equal to positive or negative 3. And you can check that. If you square 3, you get 9, and 9 minus 9 is 0. Well, if you square a negative 3, you still get 9, and 9 minus 9 is 0. So both of these do work. So how about this example? The squared part is already isolated, so we can go right in and take the square root of both sides. And you're supposed to remember to take the positive and negative of the right-hand side. Well, this one's not really going to matter because the square root of 0 is 0, and 0 doesn't have a sign. So we end up getting 2x minus 1, because these two go away, is equal to 0. Go ahead and add 1 to both sides. You get 2x equals 1. Divide by 2. So x is equal to 1/2. You can also check this one. 2 times 1/2 is 1. 1 minus 1 is 0. 0 squared is 0. So that one also checks. How about the next one? We need to get the stuff that is squared by itself. So to do that, we need to subtract 8 from both sides. This is 0. I get x minus 3 all squared is equal to negative 8. Well, then I'm supposed to take the square root of both sides, and don't forget plus or minus. When I do that, I get x minus 3 is equal to plus or minus the square root of negative 8. This is where you have to remember how to take the square root of all these different types of numbers. Well, negative 8, when we break it down, is negative 1 times 2 times 4, but 4 is 2 times 2. You're under square root. Remember, the square root of negative 1 is I. These two can partner up, so 1, 2 comes out, but you still have a 2 left underneath. So you end up getting 2i square root of 2, and it's plus or minus that. Well, you still need to add 3 to both sides. So you end up getting x is equal to 3, that's the real part, plus or minus 2i square roots of 2. This is going to be your solution. Now, is it possible to check something like this? Sure it is. You can use those nice calculators that you're required to have. Your I button is, let me see if I can find it on my calculator. It's the decimal button. So on my calculator, I push second decimal to get an I in there. So the way I would work this is I would push in 3 plus 2, and then second I, and then square root is the x squared button. So you would do second x squared, 2, and then close the parentheses. And then you would push stow x, enter. So you just stored every bit of this in x. Then you can just type this in exactly like it is, and hopefully you get 0. And then you would need to check the negative one as well. And you do that using the same format. The next method we're going to talk about is the factoring method. So the very first thing you want to do is make sure your equation is in standard form for a quadratic equation. We have ax squared plus bx plus c equals 0. It needs to be in this form before you can use the factoring method. This first example is in that form, so we factor it. Factors of negative 12 that add up to negative 1, well, that's going to be a positive 3 and a negative 4. Once you have both of these factors, you set each one equal to 0. And solve. Subtract 3 from both sides. And add 4 to both sides. So x is equal to 3 or x is equal to 4. Or negative, sorry, excuse me. And you can check both of these by simply substituting them back into the equation. So what if your equation is not in standard form like this one? If it's not in standard form, then you're going to have to put it in standard form. So we need to multiply all of this out, move the 8 over, and then factor it again. So this one would give us x squared minus 4x plus 3x minus 12 equals 8. I'm going to do two things at once here. I'm going to combine these and subtract 8. So we end up with x squared minus x minus 20 equals 0. This will factor. Factors of negative 20 that add up to negative 1 will be a positive 4 and a negative 5. Set each factor equal to 0 and solve. Subtract 4 and add 5. So your two solutions are negative 4 and 5. So this last one is already in the correct form. We just need to find factors of negative 18 that add up to negative 7. So that will be a positive 2 and a negative 9. Set each factor equal to 0 and solve. So we subtract 2, x equals negative 2, and add 9. And that's how you use the factoring method to solve a quadratic equation. How about completing the square? For completing the square, we need to write down the first two terms, move the constant over, so we're going to subtract 7 from both sides, but leave a little space where you took that away. We're going to leave this space in here. Remember, whenever you complete the square, you take half of the middle term and square it. So half of 6 is 3, and 3 squared is 9. You add that to both sides. Whatever you do to one side, you have to do to the other side. The left-hand side will factor into a perfect square. Remember that from when we talked about circles? So you're going to get x plus 3. This is your x, this is your plus, and then the 3 comes from either half of this or the square root of this, whichever way you like to think about it. So then negative 7 plus 9 will be 2. Now this looks like those first problems that we did. We can use the square root method. So we take the square root of both sides, and don't forget plus or minus. So we get x plus 3 is equal to plus or minus the square root of 2. When you subtract 3 from both sides, you get x is equal to negative 3 plus or minus the square root of 2. That's going to be your solution. You can also check this one. Remember, just store -3 plus the square root of 2 and then type in your equation. Hopefully it's equal to 0. And then you type in the -3 minus the square root of 2, store that in x, and then type in your equation. So if you're trying to complete the square and your leading coefficient is not 1, you have to do something first. So let's see exactly how this is going to work. What you need to do is divide everything by that leading coefficient. So you divide both sides by 2. So you end up with x squared minus 3/2 x minus 2 equals 0. Now it is in the correct form, so we need to move the constant to the other side. We get x squared minus 3/2 x equals 2. Remember, you have to add 2 to both sides, right? Now we're ready to complete the square. Take half of 3/2. Half of 3/2, that's 3/2 divided by 2, or 2/1, right? Remember how to divide fractions? 3/2 times 1/2, so you get 3/4. 3/4, you're supposed to square it, and you get 9/16. That's what you add to both sides. The left side will factor into a perfect square. You have your x and your minus, and half of this was 3/4, or the square root of this is 3/4. And then you have 2 plus 9/16. Well, 2 is the same thing as 32/16, right? So we have 32/16 plus 9/16. That will give us 41/16. Now we go ahead and take the square root of both sides. And don't forget plus or minus. So these two go away, leaving us with x minus 3/4 is equal to plus or minus the square root of 41 over the square root of 16. Square root of 41 over, well, the square root of 16 is 4, right? So we add 3/4 to both sides, and we get x is equal to 3/4 plus or minus the square root of 41 all over 4. So you could leave it this way, or you could say that's 3 plus or minus the square root of 41 all over 4. And you can do that because they have common denominators.